we've been recording all of these, but we've been recording these in, and Adam, take no offense, the jankiest possible way. I mean, Adam actually had a 9-part tweet thread describing what he was doing to record these things. Because my view is, how is it?
Sorry.
How'd it go?
Yeah, I'm good. I was able to start recording on my BlueStacks rig before I was able to get in here properly. So,
I mean, it just sounds like something you use for Bitcoin mining. I mean,
it was really close. I know.
So we had this great space last week with Matt, and then we had this. We realized that we had actually, or Adam, afterwards, you must have had that horrifying sinking feeling.
Oh my God.
So yeah, walk us through it. What happened?
Oh God. So, I mean, the what happened, I don't know is the short answer. But
that's always fun.
So I get off the call, and it's gone an hour and a half. It was awesome. And Matt, I know you're here. It was terrific. And if you haven't listened to it, you should go listen to it. And it's the one of these that I have shared with my non-technical friends. One, because I've been a little embarrassed to explain to them what our Twitter space is, and that I have one, and that I would do it on a regular basis. But I sort of feel like the folks for whom this content is designed is a very, I'm doing a lot of work there. Kind of find us, I think, like the 100 or so, 200 who show up, and then like the 400 YouTube views. But last week, I think, was extremely approachable and important. So I get off that call, and I'm like, sweet, let's hear the recording. I got to get it up. And
0 bytes.
It is 6 seconds of just angry static.
Oh
like,
no!
You're gonna be shitting me. So so at a moment of like, okay, QuickTime recording player, where else might you have put these bytes? And there aren't that many places, right? Because it's like a Mac and it's like an app, and it's either going to dump it all into the trash or maybe some temp file, but there was no big temp file. So anyway,
so Matt and I are DMing because I'm breaking the news to Matt, being like, so the recording maybe lost at sea here, and Matt's like, I'm sure it's fine. I'm sure it hasn't been I'll help Adam. And he kind of just comes back, Matt, I know you came back to me a couple minutes later, being like, yeah, the recording may be gone. We may actually, but then it had that great ending because we asked the internet, and the internet had 2 delightful answers, each as surprising as the other. I felt. I don't know, Adam, how you felt. One was that Twitter records all these, which I knew, but recently they were making it available to you if you downloaded all your personal information, which I also have done because this is actually the only way I've been able to get, if you have a long DM conversation where you want to record that, the only way to really get this is to download all of your personal information from Twitter. There's no real API. I mean, Twitter, I love you, but how about some APIs around some of this stuff? And all the APIs are basically turned off, so you have to download all this stuff. Have you done this, Adam? Have you downloaded all your personal information from Twitter?
Never.
It's fascinating. I mean, they collect a lot of information for you. It's very valuable, but you can only do it once every 30 days. Because they want you to prevent you from using this as an API. The recordings are deleted after 30 days, and the recordings may take between 24 and 48 hours, but quote, may take longer to show up. So we're like, okay, what do we do? So we're thinking we're going to request the recording on Wednesday. And then meanwhile, someone who if you're here, God bless you, was like, actually, I think I've got a bootleg recording of this. Like, that is great.
Yeah, and they just kind of showed up in my DMs and were like, yeah, I've got it here. I missed the first 5 minutes. I was like, man, I will take it.
That is so great. Thank you for wearing a wire. Or I don't know, because people recording, I don't know, whoever is recording everything about their lives. God bless you.
Yes, thank you, our police state friends.
Yes, absolutely. I think it's great. I do feel strong. So I actually do feel strongly about that. I'm happy, and maybe this makes me a bit of an outlier. I'm happy to be recorded more or less all of the time because I view the positives of being able to amplify those conversations and people being able to consume them when at a time that is convenient for them as opposed to us is so much more valuable than the. I mean, I feel like I don't have any privacy anyway right now, so But
there you go.
But I'm an overshare.
Yeah.
All right, on to the main event. So I think I had seen. Have you watched the? Did you watch this talk, Adam?
No, so I had not watched the talk. It had been in my queue, and I am so glad that you raised it to the top of the queue because it was so amazing. It was awesome.
It was great, and I think I had seen someone else had tweeted out like a screenshot of this thing,
Yeah, there were some slides that floated around,
and the slides were
um,
juicy. I mean, they
and I was
were.
like, yeah, these look like these are our people. Like this is gonna be great. Like this is gonna be right up our alley.
Okay, so and then Adam, I think you and I may need to confess but you and I both have had a complicated relationship with graduate school and academia. We
Yeah,
had,
I think yours was more complicated than mine, in part because you,
is that a
I think you,
challenge?
you, you poured, you kind of poured your, as I was contemplating grad school, you were kind of poured your own feelings of it into, my cup, and I had to like drink it down.
Wait,
But yeah, no, I agree.
wait a minute. Are you somehow? I was gonna. You and I were
I'm,
gonna hold
I'm,
hands and have an inferiority complex together, but I'm concerned that you are now.
I'm blame thanking you. I'm
You're
blame thanking you.
blanking me.
Yeah.
You're blanking me, I guess. Yeah, but so I just have. Well, I think like a lot of people, a complicated relationship with academia. In that I view I viewed myself as getting a PhD as the pinnacle of intellectual achievement, and that unwinding and realizing that that's actually not what I wanted to go do, and I could actually go into industry and go do interesting work, um, was complicated, I wod say. And I actually, and I still believe that I don't have a PhD yet, sadly.
Wow.
Isn't that
Good for you. I mean, a lifelong learner.
well? But because both my grandfather and my mother got PhDs very late in life, so I think I've got some like genetic mutation.
Yeah. No, hey, go for it. I say, let's do this oxide thing for a little while first, or maybe you can
No,
do
that's what
some
I'm saying. I'm
extension
applying to
programs.
grad
Yeah.
school tonight, Adam. This is what I'm trying to tell you. This is what I'm leading up to.
Actually,
I'm leaving. I'm going to
Ryan
grad
has
school.
accepted. What he's trying to tell you, Adam, is that he's leaving. Actually accepted.
Good. Okay. Well, this is an awkward forum for that, but I support that decision.
I just feel like I wanted to make sure the recording was on and I could do it. No, of course not. Of course,
Good.
no.
Only have to do it once.
Yeah,
No, this is
none of
gonna.
it. That's not true.
Right. None of it's true. But what is true is that I think I've always thought highly of academia, and I have wanted academia and industry to work together to help one another out. And for academia to get to be solving problems that were interesting and relevant to industry, but not doing so in a way that was presumptuous or elitist, and that I would say doesn't really happen. That's basically.
Well, I think that maybe that dovetails to my dalliance with grad school, which was the two internships, the two most significant internships I had when I was an undergraduate were in the Microsoft Research Graphics Group, and then at Sun Microsystems in the kernel team.
Okay, in the graphics group at Microsoft, are you not even allowed in the same elevator with PhD? I mean, don't you have to like take different? I imagine that being a very stratified society.
It was not, and in fact,
Really?
as a first person who had just finished his sophomore year of college, and I gave a presentation like my third week of my internship to a room full of like 15 people, 3 of whom have shading algorithms named after them. It was terrifying, and incredibly flat. And just as a quick vignette, Jim Blinn of Blinn Fong Shading would sit around at the lunch table with me and explain how he watched The Simpsons with his wife, which took a lot of time because they watched it twice, the second time pausing it. So very, very flat. And I think and also I'd say that in that Microsoft Research Graphics Group, there was a lot of that interplay between some of the work going on in games and Xbox and their research. And so I think that kumbaya of industry and academia living side by side was much more realized.
Well, and I would say that of the academic domains, I think graphics has done this well. And of companies, Microsoft has done this well. So it's actually not very surprising that Microsoft graphics is probably was pretty good.
Exactly. No, exactly. So I agree. I think that's what that's another part of the dichotomy for me was, I had a lot of interest in graphics as an undergrad and a lot of interest in systems. And so it was sort of like industry and systems or academia and graphics. And obviously, like I showed up at Sun thinking, oh, I'll do this for a little while, and then go to grad school, and it's been longer than a little while now.
Am I about to be blamed again? Is this where this is?
No.
Okay.
I have no regrets on that, and I think that.
Can I get that? I mean, just routine. Can I just get that in writing? I'm just going to need that to be notarized.
You can, but just remember, like I can cut this out of the of the recording.
I am certain he said that he would, but I now can't find it.
Yeah, I dreamed it. You have to get the data dump again, but you got to do it within. You got to wait 25 days or whatever until you get it. Yeah, so. I think that part of it was I saw the kind of work that we were doing at Sun being totally different than the systems work going on in academia, and just sort of felt like it was disconnected. The academic work was disconnected from pragmatic, real problems.
Yeah, which it is. It definitely was and is. I feel systems it's been not good in systems, and that was what I was kind of waking up to as an undergraduate. Is that the academic systems, that the more interesting systems work that was being done in industry. And the have you listened by any chance, and only listened, not watched, because they did not video it, the keynote I gave at Usenix ATC?
Yes, and in fact, when Moffey started his talk and said, I'm not going to be a James Mickens, but I am going to vent my anger and frustration. I was wondering if that was just you, or if there's a whole lineage of anger and frustration.
I had the same question. So Usenix invited me back to give the opening keynote at ATC, but with no vetting of me and no guidance about what they wanted me to speak about. In particular, they're like, "Oh, but do you want me? What would you like me to speak on?" They're like, "You can speak on whatever you want." I'm like, this person has never seen me talk. Like, that is way too much license.
It's like a Festivus airing of grievances.
I don't think that's what they realized they were signing themselves up for. In particular, what I ended up talking about, which I think is getting us to Timothy's piece, he alludes to a little bit, although I don't think we need to necessarily fixate on, but is the problem in academic systems, and in particular, the problem with the fact that we use in computer science, we unfortunately use conferences as the publishing vector and not journals. And it leads to lots and lots and lots of perverse incentives. It does not yield good results. And this is not a controversial opinion. Like, I think everyone kind of knows this, but nobody knows how to change. And the origins of this was that computer science was moving too quickly for journals. That unlike, biology and chemistry and so on, like, we are moving really fast. So we can't be in a journal because by the time it's in a journal, it's obsolete. And so we need to publish in conferences. And Adam, have you ever talked to like other scientists about this?
No, not really.
Oh man, it's like explaining Twitter Spaces to your friends where you're having to repeat it 4 different times and they're blaming you. They're like, "No, you are misunderstanding." I'm like, "No, I'm not misunderstanding. I know." It's like, "No, but what you're saying is bonkers. Like, that you're saying that you publish in the conferences? That's not what a conference is." I'm like, "Yeah, no, I know. You're not mad at me. You're and so, and he gets that a little bit, but I think the thing that is, and he definitely picks on OSDI for good reason. But the thing that he gets to that I thought was way more interesting, obviously, is talking about what the modern operating system does and should look like. So you saw this for the first time, and Dan, I think either I turned you onto this, or you turned me onto this. I can't lose track, but I know you saw this as well.
Yeah. You pointed me at it, so not the other way around.
And so what y'all think of it? I thought it was great. I thought it was exciting, invigorating, interesting, very forward-looking, and it had with some spice to it. I like the fact that he was kind of calling some things out in terms of calling out. I mean, I've got some other comments too, things he gets slightly wrong or things that I'd like to add to. But what did you think overall?
Well, yeah, at first I loved it, and I thought that one of the most insightful pieces was that OSDI was intended to be about the design and implementation of operating systems, and that he's not denying that there are operating systems that of which Linux is a component on modern systems, but rather that it is accreted and not designed. And I thought that was such a great point to kind of consider the design of the holistic system rather than just viewing parts as static and then working around them like as though they are impossible to change.
I had the same feeling, and his word choice was just beautiful. If you recall, his word choice was, and his timing is very good about the way he says, these were not designed, they congealed. And I'm like,
that's right.
Man, why is congeal not in the rotation for me? I feel that was, game respects game on that one. I just thought that was a great metaphor. It has like the grease, the cooling grease that just feels so. It just nails it. I feel because it did congeal. It was not. You would not design it this way.
Absolutely. Dan, what do you think? If you're there, Dan.
Dan is...
Sorry, I muted myself. Can you hear me now?
We can, yeah.
I totally know how technology works, and therefore I'm qualified to comment on this.
That's right. Exactly.
Perfect.
Could you please build me a computer, sir?
Yeah, right, exactly. I thought that the content was absolutely on point. And I think, so I shared this talk with some members of the Unix Heritage Society mailing list. And some of the feedback I got from those folks was actually quite insightful. One person said, well, okay, what's taking them so long to get there? A lot of other people said, yeah, that's great, but like who cares about the actual operating system? Like what about sort of distributed systems? Like our world is very different than it was a while ago. Now, I think that we care. It's
right.
What I'm saying. Like microservices have to run on some computer somewhere at some point, and being like, Kubernetes is great or whatever the case may be, but that does not drive the interrupt controller or the Ethernet or the storage device or provide a process abstraction or whatever. So I thought the content was absolutely on point. It reminded me very much of Rob Pike's talk from 2000, where he talked about system software research as irrelevant, in the sense of being a polemic for the systems community. But I know you guys have some feels about that. I actually kind of hear that.
Yeah, no, I think I can see Cluo unmuting himself. The polemic, I feel it definitely has. I mean, I liked that it was provocative the way the polemic was. The thing I view as fundamentally different from Pike's polemic. Pike's polemic felt kind of nihilist to me, and like
it was exhausting.
And the thing I liked about, and this is like hard to dial up, but I admire it. Roscoe has got like indignation, but with a twinkle in his eye and a look to the future. So it feels much more uplifting than the polemic. The Rob Pike's polemic is just like, all right, so let's just all like walk in the traffic, and without I think some of the, and I think the other frustration, Josh, I mean, obviously love to get your perspective on this. I think the other frustration of the polemic is it felt like it ignored some of the work that had gone on outside of academia. Like lots of things had actually happened. And I think especially as a technologist gets older, you have to, there's going to be a temptation towards nostalgia and romanticizing one's youth and past and thinking that nothing interesting has been done, or that all the problems have been solved. And I think all those temptations really need to be resisted. They're really, really dangerous. And because to young people in the discipline, they don't feel uplifting. They feel like you're just slamming a door in their face. So Josh, am I reading too much into the polemic to Rob Pike's polemic?
I mean, I think it's like a cranky person that's, I don't know, perpetually bumfuzzled that nobody has adopted his specific thing, and ergo, like, the field is moribund. Like, all right, I guess I'll go back to bed. Like, yeah. Okay.
I mean, I think that's a little unfair. So I've met Rob Pike a few times. I wouldn't say that I know him well, but I can say that he presents himself in a certain way that would lend to that interpretation, but that's not necessarily what he means. The way that I sort of interpreted the 2000 polemic was, hey, we're not doing stuff that people are interested in. We should really think about what we're doing, and we should start doing stuff that people are interested in. But I can totally see where it comes across as like, the world doesn't run Plan 9, you're all stupid, I'm leaving. You know,
Well, but also
I-
just also critically, like it appeared to reject the value of incremental improvement, which honestly, like incrementalism is like it's the shoulders we all stand on when we ship things.
yeah, I think that's true. I also think it's a little bit, you know, I mean, like when we talk about systems research, right, and building whole systems, like there is a question of like, do we ever build a new whole system kind of from whole cloth? Or, you know, in Rob's case, or actually in Mothi's case, do we like spin the thread, you know, go shear the sheep and wash the stuff and card it and then spin the thread and use that to create the cloth from which we build the new system? And I think it's fair to say that for the past, I don't know, 20 or 30 years, the answer very much has been no. And, you know, the industry and academia both have been very much dominated by Linux specifically, more generally sort of the Unix process model and system call model. So like the systems we have these days are very much in the Unix mold, and that's not necessarily a great thing. I mean, I don't think that's bad. I think that's great for shipping systems. But, you know, is there space to ask questions about, hey, do we want to change the process model? Hey, what would it look like if we did different things with memory? Hey, you know, what if we wanted to do a real single system image again? You know, we don't ask those big questions. And I think that's kind of what Rob was saying. And to a lesser extent, I think that's what Mothi was saying. Although Mothi's focus was almost exclusively on the hardware. He didn't, for example, call out like, you know, the Unix system call interface. He didn't question at all whether that's a good fit for modern systems. And a lot of folks will claim that no, it's not. But he didn't mention it at all. Just didn't come up.
Well, I'll tell you that frankly, I kind of appreciate it, because I think that the problem that we've had is that because we have settled on an application model that is functional. Whether, I mean, there are problems with it, I think there should be room for kind of radical rethinking. But as I think we've also seen over and over again, that software takes a long time to build. We've built a lot of software on these extended abstractions. Josh, to your point about incrementalism, there are a lot of good reasons to retain these abstractions, so we don't get into the kind of the software projects of the 90s where you spend, you know, just tons of resources on something that doesn't end up shipping because you're trying to solve every problem at once. What we have done, I feel, is because we have accepted some of that application model, we have at the same time said, okay, well, there's nothing to be done in the operating system. And what I loved about Timothy Roscoe's keynote is like, actually, no, wait a minute, hold on. There's lots of problems to be done, because while you've been dismissing the operating system as kind of done, there's all this stuff that's been congealing downstack, to use his language, congealing underneath you that is really germane. And I think if anything, I feel that he understates it. He actually doesn't know, he's even righter than he thinks he is in that. And I do think that like one of the things that I would say is like a major point of clarification is one of the huge problems is the cores that he's talking about are too proprietary right now. That the world he's talking about is not well known, in part because for many microprocessors, that's only happening under NDA. And that is, and you don't even control the software on there. Like to put it in, you know, stuff that's very relevant to us at Oxide, but you can rephrase this in terms of any CPU, AMD PSP, the platform security processor, the source code of that is not open. You know, we don't have the ability to run our own software on there. And that's a problem. So we can't see that world, which is part of the reason that the academics don't see it either.
And that's true for a lot of the components of that broad architecture diagram that he puts out there, that of which, you know, Linux occupies a tiny corner. But a lot of those pieces are proprietary and being built and designed in isolation. And so while I agree that he has a very hopeful message for academia, I feel less hopeful for the prospects in industry.
Interesting. You know, like an observation that I've kind of made through the years is that industry and academia tend to leapfrog each other on a cadence of once every like 10 years or so in terms of who's doing the more interesting work. And I feel like we're actually in an extended stretch where industry has really been leading academia in a pretty serious way now for like 20, 25 years. And that really kind of started, I think, with the web. I mean, the web really caught academics just completely flat-footed. And then it quickly became like the major application of the internet. And once that happened, there were all sorts of funky systems problems that just needed to be solved. And like, you know, people pontificating about microkernels and, you know, new whatever it was that people in academia were talking about in like sort of the mid 80s, like that stuff just became unimportant. And it was like, whatever, make Linux, you know? And
yeah, and I would also say that Microsoft sucked the air out of the room as well. That in the mid 90s, Microsoft is a foregone conclusion. OS research is effectively dead. It's been solved. Even Unix is not interesting. But to your point, Dan, all of the interesting problems now are distributed systems problems is circa the early 2000s.
Yeah, or I mean, just more generally, like operating systems are very interesting because artifacts of the operating system implementation tend to have really outsized impact on overall system performance, right? It's like if you don't get buffering right in, you know, the file system or something, like the networking stack, it doesn't matter if it's fast. Or, you know, if there's a lot of jitter in your process scheduler and you don't get the algorithms correct, then, you know, the stuff that's in the hot path isn't running often enough. And so the, you know, like tail latency is widely variable at the 99th percentile and so on and so forth. Like those are real problems that where the OS has a direct impact, and people in industry really, really care about that stuff, you know? And I think
so Dan, I think that's a super interesting point, and I think that because performance is one of those things that could be the driver of this holistic take on the system.
Yeah.
But you know, one of the places that Mothi focuses on is security.
Oh yeah.
As the low hanging fruit, and I totally agree.
Yeah.
Now, I absolutely agree that there is like a 10x improvement in security, and forgive me for kind of diving to that nomenclature, but there's not in performance. And you know, I'm going to go on a slight tangent, but tell me if this resonates. You know, I spent a lot of time in the mid 2000s, like 2010s, like thinking about SSDs, and thinking also this is ridiculous that we have this this new, I mean not that new, but we had this different kind of medium that we was pretending desperately and you know very challengingly pretending to be a spinning disk. Why was it pretending to be a spinning disk? Because everything expected it to be a spinning disk.
Oh, yeah.
And I you know I wrote this sort of naive article now in ACMQ about, you know, we should be building systems, you know, let's rethink that whole stack. And there are lots of folks that had that opportunity and had that incentive. But I think the answer was there wasn't that much of a win there. Maybe you get like 10 or 20% better performance or longevity.
But it wasn't
not enough.
It wasn't 10 times faster, or you didn't get 10 times that throughput into the disk by doing this.
That's right. But and I think you know, it's not time for the epitaph on that idea, but I do wonder, you know, what I walked away thinking from Mothi's talk was what pushes that kind of thoughtful design of the operating system rather than congealing of the operating system.
Well, yeah,
and what pushes past incrementalism.
But Adam, like my question is, like define 10x, right? What does 10x performance mean? That doesn't necessarily mean that your job is served 10 times faster. That may mean that you can make changes to the operating system 10 times faster. So when you find that there is a problem, you can hone in on it much quicker, you know?
That might be where the some of these I guess pathologies actually come from. Like you know, he mentions your baseband processor in your mobile phone that just memory maps everything, and you know that's major security problem, whatever. But you know, I, for instance, have been looking at these ESP microprocessors, microcontrollers. I don't know if folks know these things, but they're these really cheap microcontrollers that are built in Wi-Fi, and they are super popular because there is another core on the die that runs a firmware blob that handles all your network stack for you. And you know, embedded programmer that wants to build cheap IoT device has an AT command interface. That blows my mind. And you know why? This is a new chip, a new system. It's commercially successful. Maybe it's just because, you know, easy always wins.
Yeah, I think this is an interesting point, and I also, Adam, I think kind of the point you're making as well. I think that we over enshrine performance a bit. Performance is not the only axis of a system, and I feel that the operating system, and I feel like even I actually went back and read the paper he referred to as 2011 paper, and where they try to make the case for the operating system in terms of performance alone. And I feel that if you're trying to make the case for the operating system strictly in terms of performance, it's kind of a losing argument because, and I think that we would also acknowledge that like actually like memory protection does not make the system faster. We're not doing that to make the system faster. We're doing that to make the system more reliable. And I think, Dan, to your point, that a system that actually like that stays up, that allows for software to be developed more quickly upon it, that is secure. I mean, there are these other axes of the system that I feel have honestly been kind of ignored, or rather, systems tend to be monomaniacal in their focus on one of these dimensions, when in practice, what we actually need to do often is balance them. We can't give up any performance. We can't have an operating system that is going to cause you to sacrifice performance. That's obviously also a losing bet. But we need to kind of break some of these false dichotomies, I feel, and deliver. We actually need to deliver a balanced system that has these other properties, not just performance.
Yeah.
So I feel like the current challenges in operating systems will be very much focusing on, well, actual security issues. So we were just talking briefly about web platforms. So on the web, we're starting to expose hardware directly, right? Like USB interfaces, for example, or Bluetooth, stuff like that, which can be very, very severe. And on the other hand, we are coming up with new operating systems. I mean, Mothi himself acknowledged the Harmony OS from Huawei. There is also Fuchsia, and I think that would be something that people should really jump onto these days.
Yeah, I mean, we talked a couple of weeks ago. We talked about Hubris, the one that we're working on at Oxide. So yeah, I agree with you. That there should be more new systems, and those systems are going to be smaller, and I think they are going to be focused on one piece of the puzzle that he's got. Because I do feel that for the other thing that merits clarification is when he's throwing up the architecture and kind of circling, where Linux is running, where that kind of traditional process model is running, versus all of these other cores. That is not by area, heat, or draw. That is by architecture, by blocks.
Oh, yeah. I mean, Linux is chewing up the most dollars or whatever in terms of the components of the CPU.
On every
components of the system,
right?
That map definitely kind of reminded me of the election maps that
right.
That's right. Land don't vote. Right.
It's like, land doesn't vote, right? And all those vast tracts of unpopulated area, like that's great. But we need to normalize for CPU cycles and applications and that kind of thing as well.
Right, and I kind of feel that hey, and then maybe this is where you might disagree, but I kind of feel like, hey, we should not. I don't necessarily think he says that this kind of CC Numa view of the world is a fiction, it doesn't exist. I'm like, no, it exists. It's just that there's this other part of the world that also exists and is very important, and that's the part that has congealed. That's the part that I think we can whether I also feel like we don't need to make anything coherent necessarily. I mean, we're certainly not going to have a single system image span your M4s and your A35s or whatever on this SoC. I don't think, right?
I kind of disagree with that in a couple different ways. I mean, I think part of the issue is that it is an illusion, right? I mean, we have to acknowledge that. It's like the sort of view of the world that we want to take from the Unix style operating system is the only thing that exists that matters is this set of big x86 cores where we're actually running processes and we're running the kernel, and nothing else exists on the machine. And it's like, well, of course that's not true, right? I mean, hard drives or whatever it is, those things have firmware on them these days, and we need to acknowledge that. And moreover, I remember when hybrid drives started coming out. These are SSDs coupled with spinning Rust, and there's a caching layer with some DRAM in it. And I remember thinking to myself, how many like broken, buggy copies of the Linux kernel are shipping on your hard drive these days?
Or in your DIM. This is what they were doing for Optane when Intel was having still unspecified problems with Optane because they refuse to tell you how it works. So it's hard for you to help them kind of diagnose their manufacturing problems. But for Optane DIMMs, they would have them fronted by DRAM, and then you've got firmware in your DIM that is going to be syncing what you thought was DRAM. I mean, it's like, no, I don't want firmware in my DIM.
Yeah, exactly. Like, I want to be able to reach in and control that stuff. But more to the point, like, where I think he was really kind of going with that point was like, look, hey, because we want to continue to provide this useful fiction to Linux specifically, and more generally Windows and other operating, like for all intents and purposes, Windows, Linux, Unix, etc., are all effectively the same system architecture as far as this talk was concerned, right?
Right.
Meaning, we don't take this sort of like view of the world. Yes, they had different process models and threading models and memory management and so on and so forth. But for all intents and purposes, we can lump them into one category of system. And what he's saying is effectively like, because we want to continue to provide these programming illusions to those systems, the firmware designers and so forth are going to continue to build things that like assume this ossification of architecture. And so those lines become deeper and yet more entrenched at the same time. It's like the further we go down this path, the harder and harder it is to root those assumptions out of the system. Will we ever end up with a system that's like a single system image that spans like Cortex-M profile processors and I'm sure there's an 8051 floating around in a modern piece.
There's always an 8051.
Yeah,
they're like spiders. You're never more than like 3 feet away from the 8051.
Yeah, but I mean, it's like, no, we're not necessarily going to ship a single system image that includes the blobs that run on the Cortex cores and the blobs that run on the 8051 and the blobs that run on the x86 cores. But that's not necessarily what he's talking about. I think what he meant was like, hey, are we going to have an architecture where we acknowledge the existence of these other things? And we architect systems so that maybe it's not the same image that's running, but these things are aware of each other and they're designed to coordinate and communicate with each other. Because right now that just doesn't exist.
That does not exist. No, I totally agree. And this is where you get to like one thing I really wish he had called for, but I understand that this is a polemic towards OSDI, not the industry. But we absolutely, positively need open hardware and firmware in order to be able to collectively make progress on this problem. And I know that, I mean, obviously this is like talking Oxide's book, but one of the things that's been super frustrated for us is the degree to which these things are completely undocumented. We call them hidden cores. I mean, it's like the number of like, you'll be in a meeting with a vendor, you're asking, are there any more hidden cores? Like we just found out about 2 more hidden cores in the course of this, this documentation dump or this meeting. Like what?
So you've got signed this letter. Yeah, I know.
And it's like we need the hidden cores, and I do think, especially with the end of Moore's law and more, which to me means that you're going to have more and more programmability in more and more spots. I mean, I think that I see a world in which we don't, a lot of these like weirdo components that we've got are actually replaced with M0s sitting on it's sitting on soft logic, right? If you give me an M0 and soft logic, like that thing can become, a fan controller. That can become all sorts of things that we need to actually build things. But like we need that to be open and transparent. We need to know the software that is actually loaded on that stuff. We can't have this world in which it's totally opaque.
Yeah, and that's what allows multiple components of the system to be designed and changed together. Because the reason we land in incrementalism is we ossify at some boundary, and then everything on one side of the boundary assumes that interface, and everything on the other side assumes that interface as well. And it's very hard to change those things without doing it lockstep, and it's very hard to move in lockstep if it's two companies that hate each other. Well,
yeah, this is a very good point, Adam, because I think that the ossification is kind of coming out of the best intentions of, and I blame Compaq for this, in that blame/credit, I guess, in terms of like trying to deliberately not vertically integrate a system to decouple software from hardware so you don't have to kind of constantly reinvent it. But then it has but now you have the congealing as a side effect of that.
So yeah, that's kind of one of my pet peeves too. The PC architecture was a great thing, but now the operating system vendors have abdicated any knowledge of the hardware. Just like, give us UEFI and we don't care what happens below that.
Yeah, Tom, this is a good point because and then I feel that John Masters is in here, so I can kind of pick on him. John feels that felt strongly that the ARM ecosystem needed to add UEFI, and I think a bunch of us are like, God, no, why would you? What? No, you've got a beautiful garden. Like, you don't need to have, a strip mine in it.
You're not already in the hospital. Why would you come here?
Right. Because it's this idea though that Tom is referring to that the OS doesn't want to have to change for my hardware, which is understandable, but then it leads to these layers that just feel like they're impenetrable.
Well, but that's how
even without all these hidden cores, there's hidden crap going on the important cores, right? The system management mode and all these firmware calls and God knows what.
It's an industrial structural problem, right? I mean, this is what commodification looks like.
Yeah, we need something like UEFI, but the OS guys should continue to own the hardware once the OS is up.
Tom, what do you mean by that? What do you mean we need something like UEFI? I mean, what does that do that we, what is the function that's actually important there?
Well, I actually like this ability to separate hardware and software. I mean, I think that's an architectural point. That's a very good thing. But,
so it's providing for, say, option ROMs and the ability to place things on the PCI bus and all of that stuff? Or?
Yeah, and just it lets it's a good interface to allow innovation to happen on either side, right? But for too long, the OS has totally ignored what's happening underneath that level.
Right.
If I could attempt to defend the idea of adding UEFI to ARM, now I'm not an expert on this, but as someone who has dabbled with the ARM single board computers like the Raspberry Pi and the like, I for one don't like every single board computer having its own patched non-mainline kernel and its own patched U-boot. So standardizing on hardware interfaces in the ARM world as it is in the x86 world would seem to help with that situation. Like I say, though, I'm not an expert on that, so it's just my thought on that subject.
Yeah, no, I mean, in the PC world, you had Intel providing the ammunition, but IBM drove a specific architecture, which everyone adopted. And in the ARM world, you didn't have that IBM equivalent.
Yeah, Matt, what you're identifying is a fundamental tension for sure. I mean, I think you don't want to inflict, and Tom, to your point as well, that you do want to insulate software from hardware, but you don't want those layers to start operating across purposes. I mean, this is where my view comes to, and I get to repeat from the songbook. I think that hardware needs to be open. Tom, you got a lot of white noise behind you there.
Sorry.
No worries. If the part of the problem is that everyone's got their own proprietary glop, and that they feel that they are either innovating or they're embarrassed. I think that's a
well, thing. Just so many of those blobs are rubbish. Like,
right,
I mean,
exactly.
Honestly, if I had the manual and the source, and I could fix the fact that every time I tell this server, like, now I want you to net boot, and 60% of the time it does. Like, it's like, if you could, the layering and the industrial structure and the way these things slot together as swappable components isn't really the problem. It's the fact that no one is there. There is no version of some of these. There's nothing that slots into some of these slots that I can fix.
I think the idea of these interface layers is good, but that doesn't imply that you then just sort of wholesale adopt the UEFI implementation, or that UEFI is the right solution there. I mean, there have been things that folks have done in the past, and I know a lot of this audience is going to know this, but stuff like, I don't know, Open Boot or whatever, like it addressed many of these problems many years ago, or device trees or whatever. I mean, there are mechanisms to do this, but I think, and kind of getting back to what Mosley was saying, a lot of it is that we've kind of said, we've like declared by fiat that, like, okay, UFI is the solution. Okay, Unix is the solution. We're not going to look at these problems anymore. There's nothing left to be done. And I think that that's just categorically not true. Like, there is a lot of work to be done here. And there's a lot of different reasons to do it. I mean, performance is one, obviously. Security is another. Just, velocity and extendability. I mean, like, try working in Linux sometime. It's an adventure. It's like really hard to get stuff done there. That kernel is very dense, very impenetrable. Some of the code is very, very bad. Some's excellent, some is not.
Going back to the academic problem, one problem academics have is they just can't afford the what it takes to do anything with hardware.
Yeah.
And hardware is so integrated that it's nearly impossible anyway.
So, Tom, that actually, and you are hitting on one thing that I loved about this talk that I strongly believe, which is let's build hardware. And he has got, at the end, he's like, because it is shockingly easy. Yes, hardware is hard, but it is easier than ever before to build your own single board computer, especially at low speed.
Right. Yeah, I think I made this point on Twitter that the whole FPGA scene now reminds me of the home computing scene of the 70s. So,
Tom, I'm so glad you referenced that, because that to me was so it bears repeating. So in terms of what you said in that tweet was that what you're seeing around the OpenEDA scene and KiCad and FPGAs and what's happening with like the ICE40s reminded you of the homebrew computing movement.
Right. So just a huge amount of enthusiasm and innovation and people getting by with the crudest of tools.
And people also helping one another out. I mean, I love FPGA Twitter is the best Twitter. I mean, it's a very just like supportive community, I feel. And people are not. Yes, there are different technologies, but you don't see the rivalries that you see, I think, in the ossified kind of tribes that we see elsewhere in the stack. I also think that, how many people would think that, and Tom, as someone who's kind of seen all of this, how many people today think boy, if I could get in a time machine and go back to the late 70s, it's like, well, look around you and look around for the current analogs for that, and you get involved and make some hardware. I think that I love that kind of call to action.
That's right. Well, especially as we looked back at the early days of Next and Windows NT, you do sort of have that moment of like, wow, what a time to be alive. But right now, when you've got folks milling their own PCBs in their basement with like a $200 piece of equipment, and colleagues of ours who are designing PCBs that show up like 2 weeks later, and are doing their own sort of like in a toaster oven, pick and place. It's pretty awesome.
We had a colleague who went from ideation to board out for fabrication in 11 hours. And that's a board that, and again, straightforward board, but it's a board that's been super, super useful. And we've been able to go a lot faster by having that thing. And that's amazing.
Well, wow. This is one of the reasons. So one thing I want to say about this, and this I think actually, again, sort of bears on what Moti was saying, is systems have become so much more complex. One of the reasons that I'm like, wow, I wish I could have been alive in the PDP-11 era is because I could, and I'm not trying to toot my own horn here. What I'm trying to highlight is the simplicity of that system. I could probably fit a good chunk of that into my head,
There are efforts, though, to develop simpler systems, some of them based on FPGAs. Have any of you guys heard of the Precursor project?
No, tell us about it.
On Crowd Supply. So it's an FPGA based SoC. It's an FPGA based RISC-V SoC with some crypto accelerators in it. It's really designed for like security sensitive applications, and it's in a mobile device form factor. So
but
Go ahead.
And that's
And he's
that's totally
developing,
cool.
and they're developing their own OS for it. Ground
in
up.
Rust, in fact.
Yes.
It's called Zeus or something like that.
Yes. XOUS. Zeus.
That stuff is cool, but that is not the same thing.
XOUS.
Right?
Why? No. You'll be
Yeah.
spelling that out for the rest of your life. Yes. Sorry, Dan. I was still getting knocked back by the spelling of Zeus that they will be.
No, that's cool. I mean, but the thing about stuff like that is that's just not the same thing, right? I mean, like if I want to build a large scale server, that's a massive undertaking, even now. And we see that at work, right? I mean, like it's a daunting task.
Oh,
yeah, you're right. But I was kind of supporting the point about for people who wish they could have been there for the homebrew computer club or whatever. I mean, there are effort or for people who wish they could have been there at the time of the PDP-11. There are contemporary efforts to develop simpler systems.
So the conclusion of the statement that I was trying to make there, though, is that like the PDP-11 was the top. That was like a very high-end machine for its time. Yeah, it was a mini computer. It wasn't a mainframe, but still, like that was a hot box, right? That was a very advanced machine.
Gotcha.
There are a lot of systems that I think, like Arduino's kind of opened up this wonderful flowering of creativity in the hardware hacking side of things, and that's great. But I'm not going to try to run a large scale organization off of an Arduino. Like that doesn't make any sense.
So Dan, true, but the flotilla of CPUs that, and I think is only going to increase in number, that surround that server, this stuff is actually pretty germane for, right?
Yes, but like when the academic folks are talking about building new systems, right? And that's again kind of going back to the focus of most of the talk. It's like, why aren't we building new operating systems? It's like, well, what are those operating systems going to do, right? It's like they're not going to replace Unix. And this is what Rob Pike said 20 years ago. The amount of engineering effort to produce a viable system is enormous these days in a way that it was not when Unix came around. So at the Unix 50th anniversary, yeah, can you hear me?
I can't.
Yeah, you're back now.
Oh, you're back now. Phew, oh God, I thought that was me.
Oh, okay.
I was convinced that was me.
No. So what I was going to say, and I'll try to keep it brief, but at ATC in 2019, some folks organized this event at the Living Computer Museum up in Seattle for Unix 50th anniversary. And I went up there. It was a super cool event. I had a great time. There was a lot of old school Unix people there. And Marianne Horton,
that was a great thing.
Yeah, that was really cool. Marianne Horton and I, though, we sat down in front of an emulated PDP-7 running version 0 Unix. And we tried to figure out how to write a B program. And eventually we came with cat or something. But it was painful.
Yeah.
I mean, you look at this and you're like, and it was very interesting because you could kind of squint and you're like, yes, okay, I recognize this. Yes, here's ED, here's the shell, here's LS. This is familiar. But at the same time, you're like, this was super, super primitive. I mean, this was not, like a modern Unix system. And the amount of work that has gone into building modern Unix systems is something that, if I was a grad student trying to do a PhD, I would not embark on something like that.
It's a great point, Dan, because it feels like with some of these more novel areas where Mothi observes that there's a lot more OSDI papers like ML, there are contributions that can be made in the span of a PhD thesis. I can grind on this for 2, 3, 4, 5 years, or 10, or however many, and make some contribution. Is the same going to be true here? Because that's also it needs to be a guidepost. As optimistic as Mothi is, most institutions, the work is going to be done for folks who are motivated in that way.
So I think but there is contributions to be made because so much of the stuff that's important is low speed. So I do think that there's this very important distinction between high speed and low speed, and the high speed parts of the system. And we're currently dealing with the DIMM placement rules from AMD, where we are dealing with hundreds of femtoseconds, and that high speed part of the system is always going to be extremely expensive to engineer. It's going to be really hard for academia to make contributions to the high-speed parts of the system. But to me, those low-speed bits, that flotilla that surrounds it, that's where the problems are all right now. And like actually, academia can focus on them. Those actually are meaningful. You actually can pick up one of those things and actually make meaningful progress. RISC-V was an academic project, right? I mean, Born is an academic project. Yeah. That's meaningful. Like that is actually, are we going to use RISC-V for a host CPU? Not now. I don't know if ever, honestly. I guess I'm still of the, and maybe this just makes me a POW of the ISO wars, but it makes me, it's hard for me to see anything other than x86, even ARM displacing x86. But I got to believe that it's going to displace x86 at some point. Is RISC-V?
It will. I mean, something will eventually. Maybe not in the next 5 years, but.
Yeah, forever is a long time bet.
Forever is a long time. It does.
I'll take the under on that.
Exactly. It'll be both. Our heads will be in jars, settling a bet. I do feel that like that is the way it ends with us. Our heads in jars, shouting at one another, trying to settle old bets in the year 2800. I mean,
dignified life.
Me not being able to recall which position that I took. Adam pulling what
insisting.
Adam pulling what I have called a Leventhal, where he injects my past self with a position that I can't verify that I held or not, but is now clearly false. I mean, of course, that's my version of events, Adam. That's
probably accurate.
One of our colleagues, Steve Cloudnick, I can't even find the tweet where actually it's referred to as gaslighting, which I thought was very funny.
It's gaslighting.
It's pronounced gaslighting, actually. That's great. Anyway, sorry. But yeah, you're right. Forever is a long time, and you got to believe that this stuff is going to be displaced in time. But then it gets to be hard to see how. All right, so how do we get from where we are to a different spot?
There's just no defined interface. If you want to change something, you have to conform to old interfaces, and we have seen over the last few years, and you're all older than me, so you will have older examples, of times people tried to make something new, for example, SMR-based device-managed SMR drives, and uses new technology, but if you want to interface with a usual computer, you have to conform to the ossified structures that expect a disk with cylinders and blocks and all these old interfaces. And if you want to change that, you have to go against all the other stuff that's built around these interfaces.
Okay, so
that's really hard.
Yeah, no,
I'm not sure I believe that anymore.
Yeah, okay. Yeah, sorry, Dan.
Well, generally, to do anything useful, you have to be compatible. But with virtualization and emulation, there's a lot of different ways to do that.
I think that's right. I think you got to be careful about how you do it. SMR is a really interesting object example. Adam, do you want to give your perspective on having watched the whole history of SMR, I feel?
I'm dealing with an issue of the recording right now.
All right, I'll proxy Adam here. He can correct me when I get this wrong. But so SMR is shingled magnetic recording, and it is basically Morris, I think this is a really interesting case that you pick up. Because like, why is SMR not ubiquitous? And so the SMR is kind of the observation that like, hey, if I can actually if I know if I can delay writes effectively, if I can group writes together, and I can shingle them, I can get higher density. And the problem is that the pathologies of getting that wrong are pretty steep. And I think the problem with SMR is that the win was just not a big enough win. It was like a 15 to 20% win, which I feel was just like not enough. Adam?
Yeah, I'm totally with you. And you mentioned Optane earlier, and it also didn't have that kind of economic niche to sit in, where it just didn't quite make sense, or there wasn't enough of an improvement to justify the cost. In Optane's case, it was the dollar cost. In SMR, it's the complexity cost and sort of the long list of pathologies that come along with it.
If you're going to change the programming model, you do kind of have to blow the doors off on at least one axis, I think.
That's right.
Or you sell it to the cloud guys who can afford to spend $1 billion to develop the software to squeeze the next 10% out of stuff.
Although my read was
I feel like
sorry, Sammy, go ahead.
I feel like that's exactly what happened with smart NICs. The business proposition there was move some stuff off of your general purpose core onto this NIC, and then you have more compute, and it comes at a cost of a lot more complexity, and so you need that scale to say, oh, I'm going to put this in a fleet of 100,000 machines.
So having worked on an offloads project where we tried to do exactly that, it does add complexity in some dimensions, but not all. And that actually, I think, like, disaggregation is probably going to be the future of systems architecture. And again, that's kind of what Mothi was driving at. It's like, we're already disaggregated, we just don't know it, right? But like, if I can move, say, some of my management plane over to a NIC, good. Then I'm not burdening my application processors with, basically system overhead function. And that's a useful thing.
It is useful, but Simeon's also right in that the extant SmartNIC abstractions, as made available to, say, the non-hyperscalers, do just introduce a lot more complexity. And I think getting back to kind of the thrust of the keynote, that there will be more disaggregation, there will be compute in more places, but what we can't do is try to make available the extant abstractions. We need to be comfortable taking apart some of the abstractions. And Josh, I think I love the way you phrased it about, if you're going to change the programming models, there's got to be a real big win. So that's not going to mean that we're changing the programming model all the way up the stack. And I think that there's going to be, there's a bunch of software that is going to need to continue to run even as we disaggregate, even as we get more cores in more spots. And then I also think the other rider I'd add on that is, it's Jesus Christ, it's got to be open. When it's opaque, we can't see how we're vulnerable. We can't see how the system, what choices have been made. And so I feel that all of that stuff needs to be open hardware and open software is really essential to get those things to have traction.
Totally agree with all of that. I mean, like, some of the complexities derive from the fact that the abstractions just are not in the right places. It's like, we say this stuff is incredibly complex because it is. Why is it complex, right? This is the Feynman thing. Like, we don't go to the next level of why in computer science. But if you say, why is this complex? It's like, well, because, the operating system expects that it's the only thing running on the box, and it's running Unix, and you have to talk to it using system calls. But if the operating system understood that, hey, my control plane is actually running over on those cores over there, right? And I'm aware of them, then now all of a sudden it can account for that, and you can simplify at that layer.
Well, that's right. As opposed to having to tell these Baroque lies to cover for the fact that this the system was designed in one way, is now operating in an environment that it was never designed for.
And to me, sorry, Moritz, go ahead.
But these Baroque lies, as you call them, they're the result of a coordination problem. We don't get the coordination between all interested parties to make some new interface, but it's an incremental process. Someone comes up with this shingled magnetic drive and has to fit it in the existing abstraction, in the existing interface. If you want to build a new machine based on the ideas of the talks, you will have to provide either everyone, your win has to be so big that everyone or the people using it are interested in investing, or you will have to provide some interface like a hypervisor with VirtIO based interfaces, so people can use your win with their existing technical, not depth, but infrastructure.
That's a good idea.
Yeah, someone should do that.
But,
yeah. Sorry, Tom, go ahead.
But this is why the Hayes command set is still buried in every device known to man.
Also, it's fantastic. I mean, come on.
That's right. Josh will defend it to all comers. Well, no, I think you're right, and I do, and actually, it's funny because in some ways the greatest act of heresy that we're pulling at Oxide is eliminating the AMI bias. We are not going to have an AMI bias. We're going to have all open firmware.
And the AST 2500.
The AMI bias, nuking the AST 2500 from orbit is actually, that one is a lot less controversial. Like literally not having a bias, the microprocessor vendors themselves, and I mean both Intel and AMD, honestly, they act like we are climbing to the top of a skyscraper with wings made of flax and we're gonna fly. I mean, they're just like, it won't work. It's like, what do you mean? Like, you don't know how to boot your own systems? I mean, they think that we're nuts for doing this. And to me, that should not be. I mean, that's a real problem, that we have got a really thick layer of unseen software that is required to provide this legacy abstraction. More, just to your point about this coordination problem, I think it's even worse than that, because we've plopped these proprietary interests in there that are really operating across purposes, which and that's I think the challenge we have as an industry.
The fact that the BIOS vendor has to make a profit, and it is not because they sold a CPU, is a huge perverse incentive. I mean, right? Like if the CPU vendor had to ship a BIOS because that's the only way they could figure out how to get an operating system to boot, that would be one thing. But they've outsourced that, or abdicated, if you will, that responsibility almost entirely.
And how is it we got stuck with UEFI without getting rid of AMI?
It's amazing, right? I mean, because you would, that Tom. So this is an interesting. So would you expand on that, because that's actually an interesting point.
Well, I'm not really an expert, but when ARM announced they were doing UEFI, I was aghast, because every experience I had with UEFI was bad. And it didn't seem to replace anything about the BIOS. It was all the bad stuff was still there, and you got UEFI.
There's no pager in the shell, and it kills me every time. Every time. I just wanted to get that in there. It's like,
have you tried setting the baud rate to 300 and typing Control
F? Not precisely that sequence of things.
Well, and then UEFI has to clear the screen so that any embedded system where you're trying to figure out what's going on ahead of that, you can't see it anymore.
But at least with UEFI, some cloud providers, at least using UEFI VMs, can boot faster, because the bootloader doesn't have to bounce stuff through the lower 640K of RAM. I read that the other day.
Huh. Yeah, but you could also just stick an ELF binary in the memory and jump to it as well. Like, I mean,
exactly. There are ways around that.
UEFI is gaslighting us all into thinking that it's the only way to boot.
We need to get Ron Minnick on here.
There was a
Linux boot.
There was a Beehive port to OS 10 called Xhive, and for the longest time they didn't ship firmware at all. They to run in the guest, that they just had effectively like a multi-boot implementation that ran outside the hypervisor. It would just do what you were supposed to do, and put the bits that were going to boot into the RAM of the guest in the right place, and then arrange for the CPU to look as if it had been through the bootloader already. I mean, that doesn't actually have to be a ROM in there at all.
If we could just provide an ELF binary when creating our EC2 machine images on AWS.
Well, you can in many cases. I mean, if you're booting Linux, for example, you can enter the operating system directly in 64-bit mode. The boot protocol is very well defined in that sense. And I happen to know that there was a hypervisor written in the last couple of years that did exactly that. And the first time that it booted, I guess, OS.
We as an industry can't rip out stuff. We have stacks, and the usual metaphor for it is standing on the shoulders of giants. But it's not. We are not standing on shoulders of each other as a very high stack, but it's a mesh. You're embedded in a mesh of all the components you're using and the dependencies of these components, and trying to remove any of them. We had the example of the BIOS. every UEFI system, or almost every system, includes a compatibility layer to BIOS. I'm younger than the specification. I'm not sure if there's any of the BIOS, and still it's going to be there for my entire career. And trying to remove stuff is so hard.
Where's the
because
crying
you have
emoji?
to.
In its
You have-
defense, the
But,
CSM.
On this topic, there is an essay by Graham Lee called "In the End, There Will Be the Command Line." Obviously, an allusion to the Neil Stephenson classic, but Graham Lee compares the situation that we were just talking about here to a car that is started by horses, which in turn are started by a human walking. So look it up. I'm pretty sure it's called "And in the End Will Be the Command Line" or something like that.
That I think is very interesting. But part of the issue with when we talk about evolving these systems, and I think that Josh actually mentioned a pretty amazing point earlier. It's like, if you want to change a computing paradigm, you've got to throw out some axis somewhere. And the reality is that computing paradigms are changing all the time. Look at the way that web development is done today compared to 1991 or whatever. It's fundamentally different in every dimension. At some point those things change. Where we're getting stuck is that we make these assumptions that we provide perfect backward compatibility for all things.
Yeah, I think, Dan, you're fading a bit there, but I think actually, and I'm looking at the time, it's a great discussion. I know we want to try to keep these to roughly an hour, but I think that it's a good note to kind of to wrap up on, that we are, on the one hand, we need to be mindful of the abstractions. Josh, your earliest point about incrementalism, there's a lot of value in incrementalism, but on the other hand, when these layers become ossified and operate across purposes, it's really problematic. And we're living in a great time. Tom, I just love your line about how this feels like the homebrew computing movement in terms of its excitement around OpenEDA, open firmware, and so on. So I think that there's a lot of interesting and exciting problems to be solved. Obviously, it needs to be done carefully, but boy, there's a lot of room for improvement, and please God, can it all be open? I think that would be my summary.
Right on.
All right. Hey, thank you so much, everyone. Really appreciate it as always. And we will we'll see you next time.
Thanks everyone.
Bye bye.